At 0956 hours, this American F-16 Fighting Falcon was climbing through 1,000 feet toward the coordinates of a heavily fortified Iranian air defense complex. Its mission was to destroy this facility, which had been designated as a primary threat to regional stability. The flight had been routine for 12 minutes, but unknown to the pilot, an S-300 system positioned near Isfahan had just locked onto him at 120 kilometers. The steady tone in the pilot's headset hit like a punch to the gut. The missile was already climbing 180 kilometers of explosive bad news, accelerating past Mach 2 in its first second of flight. At this range, impact in 80 seconds, maybe 90 if he got lucky. The pilot yanked the stick hard right while simultaneously deploying chaff, putting the F-16 into a 90-degree aspect angle to the radar beam. Pilots called notching. He held the perpendicular for 8 seconds, while dispensing chaff in programmed bursts. The aluminum strips created a slowly expanding cloud moving at wind speed, each strip reflecting radar energy like thousands of tiny mirrors that made one aircraft look like 100. The system's algorithms tried to sort fighter from false returns from terrain, but at this aspect angle, they all looked identical. Track quality degraded from solid to intermittent to lost. The 5E-55 missile suddenly, without guidance updates, switched to its backup mode, flying toward the last predicted intercept point, but the pilot had already changed course and was diving for the deck. Missiles on board Seeker activated in the terminal phase, searching for a target that was now 2 kilometers away and obscured by chaff. Its proximity fuse found nothing but aluminum rain. The warhead detonated harmlessly, sending shrapnel through the empty sky. The reason why this worked is because the S-300's radar uses Doppler processing to separate moving targets from ground clutter. It looks for things like approaching or receding, measuring the frequency shift of the radar return. But when you fly perpendicular to the radar, your relative velocity toward or away from it becomes 0. To the DA processor, you suddenly look like terrain, which is why the missile missed. The pilot leveled off at 500 feet, checking his 6. The missile smoke trail disappeared in the morning air, but he knew this was just round one. That's because the Iranian Mirage radar system uses thousands of individual transmitter-receiver modules that can steer their beam electronically, jumping from horizon to zenith instantly. And unlike older systems that give up when they lose track, this one remembers. It knows your last position, your heading, your speed. It calculates where you probably went and starts searching there first. The pilot had bought himself maybe 30 seconds. The Mirage operators were already adapting by switching to different radar modes. That's when they activated bistatic mode, and suddenly this pilot's clever escape became a trap. In bistatic mode, the radar splits itself in two. The transmitter stays at the original site near Isfahan, but the receiver sits 40 kilometers away at a different angle. Think of it like this. Normally, radar is like a flashlight, where the bulb and your eyes are in the same place. Bistatic mode puts the flashlight in one location, while you watch from across the room. Suddenly, you can see shadows and reflections that were invisible before. The F-16's radar warning receiver only detected the transmitter signal hitting him, but had no idea a receiver 40 kilometers away was catching his reflection like a mirror catching sunlight around a corner. The geometry meant that even at 500 feet below the primary radar's horizon, the signal bounced off his aircraft, traveled to the offset receiver from a completely different angle. The return was weak, intermittent, but it was enough. They had him again. This time they didn't launch immediately. They had something better in mind. 10:03 hours, this Tor M1 system got the information they needed. The crew had been waiting for the plane to reach its exact spot. A slight rise overlooking the valley, the F-16 would transit in 90 seconds. They didn't need to search. The S-300 had already told them everything. Altitude 500 feet, speed 480 knots, heading 067. Arriving in 85 seconds, the automated systems took over with mechanical precision. The phased array radar went from cold to radiating in 3 seconds. Its beam already pointed at the exact bearing where the F-16 would appear. This wasn't random hunting. This was an execution. The S-300's computers had calculated not just where the target was, but where it would be, accounting for terrain masking, fuel consumption, and even pilot psychology. American pilots following this particular valley through the sector typically chose this route. because it offered the best cover from larger air defense networks. Today, that predictability should have been the end of him. The pilot's radar warning receiver exploded with alarms. Tour acquisition, signal strength maximum, track mode achieved. He'd ambushed, and at this range he had maybe 4 seconds before missiles launched. The geometry was perfect for the Iranians. He was trapped in a valley with ridgelines on both sides. Couldn't dive, because he'd hit the ground. Couldn't climb without exposing himself to every SAM within 50 kilometers. The Tor had him in a box where none of the options were good ones. Two 9M3330 Thursals erupted from their tubes, accelerating so fast they broke the sound barrier before clearing the tree line. Each missile weighed 490 kilograms and pulled 5 Gs in the terminal phase, turns that he couldn't hope to outrun. The pilot watched them climb on his missile warning system, calculating intercept geometry. At current speed and altitude, impact in 31 seconds. But here's made the Tor truly terrifying. Unlike older systems where you could break lock and the missile went stupid, these things used command guidance until the last second. The ground radar fed them constant updates. Breaking lock meant nothing. The missiles would keep coming. The pilot had one option that might work, and it would hurt. He pulled the stick into his stomach while ramming the throttles forward, trading all his carefully hoarded energy for altitude. The F-16 upward in a maximum performance climb. G-meter pegging at 7.5. At this load, the aircraft 7.5 times normal. The pilot's G-suit inflated, squeezing his legs and abdomen to keep him conscious. Gray started creeping in from the edges of his vision. Anyway, through the narrowing tunnel he watched his altitude. 2,000 feet, 3,000, 4,000. At 4,500 feet, he fired every chaff cartridge he had while rolling inverted and pulling through. The F-16 traced a perfect barrel roll, while aluminum strips created a radar snowstorm. The first missile tried to follow the radical maneuver, but couldn't match the roll rate. It passed 100 meters below, close enough that the pilot could see its control fins working. The second missile was smarter. Its guidance computer predicted where the F-16 would be at the bottom of the roll. But the pilot had anticipated this. Instead of completing the roll, he pushed negative Gs halfway through, bunting toward the ground in an opposite direction. The missile corrected, but too late. It overshot by 200 meters. Proximity fuse finding nothing but chaff, he'd survived, but the maneuver had cost him. Fuel consumption during max afterburner climb, 300 kilograms in 40 seconds. His airspeed had dropped to 180 knots, barely above stall speed with his ordnance still attached. And the Tor crew wasn't done. They were already reloading. The transport vehicle backed up to the launcher, its crane already swinging a fresh missile into position. The crew had drilled this evolution hundreds of times. Muscle memory and mechanical precision. Pilot would still be in range, still be slow from his defensive maneuvering, still be vulnerable. Commander watched the automated loading sequence while tracking the F-16 on his screen. The American was climbing toward release altitude. He needed 15,000 feet for his AGM-65 Mavericks to achieve maximum standoff range. That climb would take 90 seconds. The reload would be complete in 45. The fourth missile launched just as the pilot reached 14,000 feet, followed immediately by a fifth. But the crew had made a critical error. They'd fired both simultaneously instead of staggered. It seems like a small mistake, but in air combat, small mistakes determine who goes home. Both missiles would arrive at the same moment, creating a single defensive problem instead of two sequential ones. The pilot held his course for 12 agonizing seconds, letting his targeting pod acquire the facility below and download the precise coordinates. The missiles he was carrying needed this targeting data for initial positioning. Without it, they'd be nothing more than expensive dumb bombs. At 14 seconds, with missiles closing at 4 times the speed, he pickled both weapons. The Mavericks separated cleanly, their solid rocket motors igniting as he rolled inverted and pulled toward the Earth. 7 Gs crushed him down as the missiles tried to follow. But physics is absolute. A missile traveling at Mach 4 needs almost 2 kilometers to make a 180-degree turn. Like a freight train trying to follow a motorcycle that just made a U-turn. The F-16 could flip directions in 200 meters. while the missiles carrying all that hypersonic momentum carved enormous arcs through the sky trying to come back around. Both NIM M330s overshot, their proximity fuses triggering on empty air as they sailed past where the F-16 had been 3 seconds ago. The pilot leveled off at 8,000 feet, checking fuel, 1,850 kilograms. The extreme maneuvering had burned through his reserves. He had enough to reach friendly airspace if he flew straight and level, if he didn't light the afterburners again, and if nobody else engaged him. That's exactly when his threat receiver picked up something new. Search radar from an Iranian F-14 Tomcat bearing 240 degrees, range 85 kilometers and closing fast. The fighter had been vectored by the same network that guided the tour. This wasn't random interception. This was coordinated hunting, and he was the prey. The F-14 pilot saw the F-16 on his radar as a bright dot crawling across his display at pathetic speed, 280 knots, barely moving. The Iranian pilots accelerate through 500 knots. At this closure rate, he'd be in missile range in 3 minutes. The American pilot had survived the S-300, defeated the tour, but those victories had cost him everything. He had no speed, minimal fuel, and no more tricks. The F-14 Tomcat barreling him now was everything the F-16 wasn't in terms of raw energy state. Powerful, with variable geometry wings, and equipped with Phoenix missiles designed to engage beyond visual range. The aircraft's radar could track 4 targets simultaneously while engaging multiple threats. And right now it was focused on just one. The American fighter appeared on his screen in perfect detail. Altitude 8,000 feet and decreasing. Speed now down to 270 knots, heading 247 degrees toward friendly territory. At 60 kilometers, the F-14 achieved lock with AIM-54 Phoenix active radar missile. The weapon would fly 110 kilometers, but at that range, the probability of intercept dropped below 50%. Better to close to make sure. But the American pilot faced an impossible calculation. He needed to maintain his airspeed or risk running dry over Iranian-controlled territory. It was like standing in a duel while your opponent walked closer for a better shot. The Phoenix launch came at 55 kilometers. The Iranian pilot watched the missile drop from his pylon, motor igniting a half-second later in a burst of white flame. The weapon accelerated past Mach 4. Its active seeker head already tracking independently while the data link provided mid-course updates. Time to impact, 47 seconds. The American pilot waited until the last possible moment to make his move. What happened next shouldn't have been possible. The F-16's nose climbed through 30 degrees, 40, 50, 60. Airspeed bleeding away like water from a punctured bag. At 70 degrees nose up and 180 knots, barely flying, the pilot kicked full rudder. The aircraft's nose rotated past vertical while the fuselage continued forward, essentially stopping in midair like someone had grabbed it with an invisible hand. The Phoenix's guidance computer had been programmed to intercept aircraft, not levitating metal sculptures. Its algorithms tried to calculate inner solution for something that had effectively zeroed velocity. Failed. Tried again. Failed again. By the time it settled on simply flying toward the last known position, the F-16 had fallen through its trajectory. The missile overshot by 300 meters. Proximity fuse finding nothing but empty sky. The Iranian couldn't believe it. The American had deliberately stalled his aircraft at 8,000 feet to defeat a missile. Now the F-16 tumbled earthward, completely energy depleted, nose hunting for flying airspeed, like a brick looking for ground. The American had recovered at 5,000 feet and was now diving for the deck as the Mavericks continued their way to the target. But the F-14 had all the advantages now. He climbed to 20,000 feet and rolled inverted, looking down through his canopy at the struggling F-16 below. From up here, he owned every option while the American had none. The F-16 couldn't climb to meet him. No energy. Couldn't dive too low. No speed. It was like watching a wounded animal try to run on a broken leg. The Iranian selected an AIM-77 Sparrow for the mid-range engagement, then would follow up with an AIM-9 infrared missile for close range if needed. No radar warning for the Sparrow once it was in terminal phase. The dive attack was textbook. The Iranian pilot pushed over from his perch, accelerating through 100 knots as gravity became his ally. The F-16 pilot could only watch him grow larger in the mirrors. At 4 kilometers, he fired. The Sparrow leapt off the rail. Its radar seeker locked onto the F-16's fuselage return. But the American had one last card. He pointed his nose straight up and fired every flare he had. The magnesium pellets erupted in a climbing spiral, each one burning at 2,000 degrees Celsius, creating a wall of heat that overwhelmed the missile's guidance logic. The Sparrow chose the brightest source and flew straight through the flare pattern, missing the F-16 by 50 meters. The F-14 pulled out of its dive, overshooting again. His fuel state was becoming a factor. Another 5 minutes and he'd have to disengage and head back toward Iranian airspace. The American pilot used those precious seconds to nose over and run for the deck. Engines at military power, racing toward friendly territory, now just 75 kilometers away. But first, he had to survive what was waiting at the next air defense position. At 10:14 hours, the F-16 pilot skimmed across terrain at 50 feet, engine coughing on the last dregs of fuel when tracers erupted from a ridge ahead. A Vulcan air defense system had waiting exactly here, positioned by the same air defense network that had orchestrated everything else. 6-barreled 20mm cannons firing 900 rounds per minute each. Radar guided, effective range 2.5 kilometers. At this altitude, this airspeed, the geometry meant he'd fly straight through the stream in 2 seconds. The pilot didn't think. Thinking took too long. He rolled inverted and pulled, flying upside down at -G, just meters above the ground. The cannon rounds passed overhead, so close he could hear them crack past the canopy. The Vulcan gunner, surprised by the inverted approach, cranked his turret down, walking the stream of tracers toward the F-16. But tracking an inverted target at 50 feet meant the radar kept trying to lock onto the ground return. The system hunted between aircraft and Earth, confused. 3 rounds punched through the vertical stabilizer. Another 2 punched through the right wing. Warning lights illuminated across the panel. Hydraulic pressure dropping. Flight controls degrading to manual reversion. The stick now fighting him like it was connected to the control surfaces with concrete instead of cables. But he was through, trailing smoke and hydraulic fluid, but still flying. Behind him, the Vulcan crew radioed his position to every unit in the sector. Let someone else finish him. The pilot checked his instruments through the forest of warning lights. 90 kilograms of fuel, 35 kilometers to friendly lines, engine temperature climbing into the red from damage, oil pressure dropping. The math said he'd make it, but he needed 30 more seconds. At 10:15 hours, 8 kilometers behind him, the first Maverick reached the Iranian command post. The weapon had flown for 6 minutes, guided by its imaging infrared seeker, locked onto the heat signature of the facility's primary buildings. The Maverick had adjusted its flight path multiple times, compensating for crosswinds and target movement. The missile dove through the facility's outer perimeter at a 70-degree angle. The warhead's shaped charge focused its explosive force into a needle-like penetration jet that punched through reinforced concrete and steel, detonating its 125-kilogram warhead in the exact center of the operations center. The blast deleted everything in 0.0003 seconds. Maps showing the latest deployment orders turned to ash. Radios coordinating air defense across the entire region vaporized. Computers containing targeting data for the entire network ceased to exist. The brain of the Iranian air defense system ceased to function. A fraction of a second later, the second Maverick found the ammunition storage facility adjacent to the command post. This was the real target. 300 tons of air defense missiles, radar components, and support equipment packed into a space designed for 150. The Maverick's shaped charge warhead punched 4 feet of reinforced concrete before the fuse triggered. The chain reaction built eventually. Each air defense system contained its own munitions and fuel. The thermal pulse from one storage section triggered the next in a cascade that transformed the entire facility into an inferno. The concrete roof contained the blast for exactly 0.1 seconds before disintegrating into fragments. The secondary explosions continued for another 30 seconds as cascading ammunition detonations created a wall of fire visible from 100 kilometers away. The pilot crossed into friendly airspace at 10:17 hours with every warning light illuminated. Engine temperature beyond red into territory the gauge didn't have colors for. 30 kilograms of fuel. Hydraulics failed, barely responding. The forward airbase materialized through the haze 8 kilometers ahead. No time for patterns or procedures. He lowered the landing gear manually using the emergency pneumatic system. 2 solid clunks from the mains. The landing gear engaged. The runway rushed up at 180 knots. He held the nose off as long as possible. Main wheels touching, bouncing, then touching again, settling onto the concrete surface. The engines flamed out as he turned onto the taxiway. Turbines spinning down with the grinding sound of metal on metal. The acoustic signature of a fighter pushed to its absolute limit. The aircraft rolled to a stop 100 meters from the maintenance hangar, leaking hydraulic fluid, streaming smoke, with more holes than Swiss cheese. The pilot ejected from the cockpit with methodical precision, his flight suit soaked in sweat, his hands trembling from adrenaline and G-force effects. The ground crew rushed toward the aircraft even as it continued to settle onto its damaged landing gear. Fire suppression teams approached cautiously, their equipment ready for any emergency. The pilot's squadron mates had already sprinted from the ready room the moment his IFF signal painted their screens, crossing into friendly territory. They surrounded him before he'd even removed his helmet, their faces a mixture of relief and disbelief. The intelligence officers were already compiling battle damage assessment reports. Satellite imagery confirmed both strikes had found their marks. The Iranian command post was destroyed. The ammunition facility was a smoking crater. The air defense network that had controlled the entire region had been decapitated in a single strike. The pilot sat in the debriefing room, still in his flight suit, still processing what he'd survived. The mission planners reviewed his flight data, analyzing every maneuver, every decision. The F-16 executed exactly as designed. Its fly-by-wire control system, its advanced avionics, its agility, all had worked in perfect concert. The pilot's training, his situational awareness, his decision-making under extreme stress, had made the difference between success and catastrophe. The damage assessment continued through the night. The satellite imagery showed a facility that had been transformed into rubble. The command post was completely destroyed, along with the sophisticated radar systems that had been coordinating the Iranian air defense network. The ammunition depot had been catastrophically damaged, with secondary explosions continuing for hours after the initial impacts. The loss represented a significant degradation of Iranian air defense capability across the entire sector. The strategic implications were profound. By eliminating the command and control center, the strike had temporarily fragmented the integrated air defense system into isolated individual units, each unable to coordinate with neighboring positions. The loss of ammunition stocks meant that even those surviving positions would be severely constrained in their engagement options. The Iranian military would spend weeks attempting to reconstitute the damaged systems and months attempting to replace the destroyed inventory. The pilot recovered in the medical facility for observation, where flight surgeons checked him for any injuries from the extreme G-forces he'd endured. The repeated 7.5 G maneuvers combined with the stress combat operations had left him physically exhausted, but otherwise unharmed. He spent hours recounting every detail of the engagement, helping intelligence analysts understand the tactical sequence, the performance of Iranian systems, and the effectiveness of American countermeasures. Within days, the pilot was cleared to return to flight status. The F-16, however, would spend months in the maintenance facility, undergoing comprehensive repairs. The damage to the airframe from cannon fire required structural welding and reinforcement. The hydraulic systems needed complete replacement. The vertical stabilizer required refabrication. The engineers worked methodically through every system, inspecting and replacing anything that had been compromised by the engagement. But the aircraft would fly again. That was the advantage of the F-16 design philosophy. It was built to survive punishment, keep flying. The follow-on strikes that had been planned for the subsequent weeks were executed by other pilots in other aircraft. The Iranians, having lost their integrated air defense capability, were forced to rely on older, less coordinated systems. The losses among Iranian air defense personnel mounted as they struggled to operate degraded equipment under intense operational tempo. The strategic advantage had shifted decisively in favor of the coalition forces. The pilot's name would be classified. His face would never appear in official reports. His aircraft's tail number would be redacted from documentation. But within the fighter pilot community, the story of how one American had survived against a coordinated air defense network and still delivered a precision strike would become legend. In squadron-ready rooms and pilot training facilities across the command, the engagement would be analyzed and discussed. The specific maneuvers he'd employed would be added to training scenarios. The tactical decision-making that had saved his life would become part of the institutional knowledge passed down from veteran pilots to the next generation. The battle damage assessment photographers documented the destruction in meticulous detail. High-resolution satellite imagery showed the smoking ruins where the Iranian command post had stood just hours before. The ammunition depot was a blackened crater surrounded by blast debris scattered across several square kilometers. The radar trailers and air defense system components that had survived the initial strikes had been damaged or destroyed by secondary explosions. The facility, which had been a nerve center of Iranian air defense operations, had been transformed into a monument to precision strike warfare. The strategic impact extended far beyond the physical destruction. The loss of the command and control capability forced the Iranian military to adopt more decentralized air defense postures, reducing their ability to coordinate complex multi-system engagements. Individual air defense units operated independently, unable to share targeting information or coordinate missile launches. This fragmentation meant that subsequent coalition air operations faced reduced threat density and lower probability of coordinated attacks. The pilot's successful egress, despite his severely degraded aircraft condition, became a case study in modern air combat. The controlled stall maneuver to defeat the Phoenix missile was dissected by weapons engineers. The inverted low-level evasion of the cannon fire was analyzed in flight dynamics laboratories. Every decision point in the engagement was evaluated for lessons that could improve future pilot training and aircraft design. The Mavericks he'd fired, following their programmed flight paths, had converted tactical opportunity into strategic success. The targeting data that had been uploaded before the engagement ensured that despite the pilot's complete focus on survival, his weapons found their marks with devastating accuracy. Weeks later, as the pilot stood in the commander's office receiving an air medal for his actions, he thought back to those moments when the S-300 had locked him up, when the Tor had forced him to trade energy for altitude, when the F-14 had driven him to the edge of the envelope. He'd survived by understanding the limitations of both his enemy's systems and his own aircraft. He'd won by maintaining tactical flexibility when every advantage seemed to belong to the opposition. He'd succeeded by recognizing that the small mistake made by the Tor crew, firing simultaneously instead of sequentially, represented an opportunity that had to be exploited ruthlessly. The destruction of the Iranian facility represented the culmination of years of training, decades of technological development, and the combination of human skill with machine capability. One pilot, one aircraft, had successfully penetrated a sophisticated, integrated air defense network, delivered precision strikes against hardened targets, and returned home despite aircraft damage that would have been catastrophic in previous generations of fighter aircraft. The story of this engagement would ripple through military aviation communities worldwide. Air forces studying the battle would examine how a single F-16 had managed to defeat coordinated air defenses, using a combination of advanced technology, pilot skill, and tactical innovation. The Iranians would study the same engagement to understand the vulnerabilities they needed to address. The Americans would extract lessons about their own strengths and areas for improvement. But at its core, the engagement represented something fundamental about modern air warfare. Despite all the sophistication of integrated air defense systems, despite the coordination of multiple platforms and sensors, despite the mathematical advantages that should accrue to the defender, success still ultimately depended on individual skill, split-second decision-making, and the willingness to operate at the absolute edge of human and machine capability. The pilot had done exactly that, and he'd lived to tell the story.